In this video, I'm basically going to be teaching you guys how you could find the area with respect to the y-axis. We've already learned how we could find the area between the curve and the x-axis. In this video, we're going to be learning how to find the area between the curve and the y-axis. So before I get into that, I kind of want to let you guys know that you don't have to do this. You can just find the area between the curve and the x-axis, but sometimes it's just more easier to find the area with respect to the y-axis, and it's just all of this is going to make sense in just a second. Well, all you do is you turn this equation, you get this equation in terms of y. Right now you have it in terms of x, right? So this thing right over here is in x. You basically got to make x the subject, and you got to get the equation in terms of y. So how do we do that? Well, you're going to rearrange. So this 1 is going to go over on that side, and then this square on top of x, this square is going to square root the entire thing. So it's going to look something like this: y minus 1 and square root. Now, is it going to be a positive square root or is it going to be a negative square root? Well, you kind of got to realize that, okay, this, your x is equal to this entire thing right over here. So whatever you throw in this thing, it's going to solve out and give you your x coordinates. So that means that all of these points that you can see, all of these points are some x coordinates. Right? This point is going to have some x coordinate, this point is going to have some x coordinate, this point is going to have some x coordinate, and so all of the points on this curve are going to have some x coordinates. Now what you got to see is, are those x coordinates positive or are the x coordinates negative? Now if the curve was obviously over on this side, then all of the x coordinates that you would get would have negative x values. But right now, all of the x coordinates that you're going to find are over here on the positive side, and so you need the positive square root right over here. So that's a little bit of functions right over there. When you rearrange the functions and do that stuff, that's a little bit of functions right over there. It's basically like finding the range. What is the range of a function going to be? That's basically how you decide what the positive and negatives are going to be. So you basically get this thing right over here. Now the first step is done. So we get the equation in terms of y. So we've already done that, right? Now what we got to do is, now we just got to integrate, just like we do with the x-axis. So now if you look at this graph right over here, it's kind of something like this. And so now if you draw rectangles, you're going to draw rectangles like this, because now you're taking the area with respect to the y-axis. So you're going to draw rectangles like this. And if you look at these, well, this right here is going to be your bound, and this right here is going to be your bound. And then obviously this right over here is going to be your curve equation, or your curve equation. And so right now, this width of the rectangle, these widths are going to be dy. Before we did this, they used to be dx. Now they are going to be dy, because this time we're talking about area with respect to the y-axis. So we are just going to now integrate this. Between the two bounds. So this is going to be the first bound right over here. We can see that the y-coordinate, remember, now we're going to look at the y-coordinates, not the x-coordinates. We're taking everything with respect to y, so we're talking about y right now. And then this is going to be our upper bound. So it's going to be 1, which is our lower bound, and then 5, which is our upper bound. And then obviously the height of the rectangle. Now if you look at this diagram closely, and we draw a rectangle right over here, you can see that the height of this rectangle is basically some x coordinate. Let's say if this is the x-axis and this is the origin, so this is 0 right over here, and this height is basically, let's say this is 3. So this 3 is basically the x coordinate. It's basically the x. And then the width again is dy, because it's on the y-axis. So we're summing up tiny rectangles, the area of tiny rectangles. So the area is going to be the height, which this times is x, times the length times the width, which is dy, and from where to where? From 1 to 5. Okay, and we already know what the x is equal to. We already know what the x is equal to, and that's equal to this thing right over here. And we know how to solve this because we can just change it a little bit, and we can say that this is basically this thing right over here. And then we've already done integration many times before, and we know how to integrate this. This is basically ax plus b raised to the power n, except now instead of x we have ay plus b raised to the power n.